Lesson 13.1 is about the distance formula and the circle formula. Here's the distance formula. It can be used to find the distance between any 2 points on the coordinate plane. So if you have x sub 1, y sub 1 representing point 1, and x sub 2, y sub 2 representing the coordinates of point 2, the distance formula can be used to find the length of the segment that joins those 2 points. Now, the distance formula comes directly from the Pythagorean theorem, and it's just the Pythagorean theorem reduced to a formula when you've got ordered pairs. So what we do is let's say I want to find the distance between these 2 points that are labeled on the coordinate plane. So what I do is you can imagine that those 2 points connect a segment that is the hypotenuse of a right triangle. And if we sketch in the right triangle, that segment would be the hypotenuse of, we have a horizontal change or horizontal leg, and we have a vertical leg. And the leg at the bottom, the horizontal leg, is actually just a length that's the horizontal distance between the -4 and the +2, the 2x coordinates. So that's a length of 6. And then the vertical leg is the difference between a vertical +2 and a vertical -1, which is a vertical length of 3. And we know from the Pythagorean theorem that if we call, instead of c, if we call the hypotenuse d, that d squared will be equal to the sum of 6 squared, which is the horizontal leg, plus 3 squared. So that d will be equal to the square root of 36 plus 9, if we take the square root of both sides. So d is equal to the square root of 45, which simplifies to 3 times the square root of 5. In this case, square root of 45, it's going to be a little less than 7, between 6 and 7. Now, when we put that into a formula, if I take a look at this step right here, where I'm taking the square root of the sum of the squares of the legs, we would get the horizontal length of 6 by taking -4, subtract 2. And we would get the vertical length of 3 by taking 2, subtract -1. So what we end up with here is the distance between the 2 points is equal to the square root of -6 squared plus 3 squared, which is equal to the square root of 36 plus 9, which we already saw from up above, is the square root of 45, or 3 root 5. So the distance formula is just the Pythagorean theorem. Now, the equation to describe all of the points on a circle also comes from Pythagorean theorem, and it is right here. In the Pythagorean theorem, this would be like an a squared, and this whole thing would be like a b squared, and the radius squared, this would be like c squared from the Pythagorean theorem. But this equation describes the circle and all the points that have a certain radius distance from the center of the circle, which is the ordered pair AB, and the radius being r. So let's look at an example of that. So here's an equation of a circle, and the first thing we want to do is name the center and the radius, and then we'll sketch a graph of the circle. So the center of this circle is at AB, but remember that this is a subtractive format and that x minus a is the center of the circle. So if we rewrite x plus 5 in a minus format, that is equivalent to x minus -5. So the x-coordinate of the center of the circle is -5, and the y-coordinate is 2. And the radius of this circle is the square root of 9, because 9 is r squared. So the radius of the circle is 3. Okay, with this circle with a center at -5, 2, and a radius of 3, what we can do to graph it is plot the center of the circle and then make 4 guide points. We can go directly up by 3, down by 3, right by 3, and left by 3. So from -5, 2, if I go up by 3, my y-coordinate will increase by 3, and I will be at the ordered pair -5, +5. If I go down by 3, I will be at the ordered pair -5, -1. So my y-coordinate decreased by 3, from +2 to -1. If I go to the right by 3, my x-coordinate will go up by 3 from -5, so I will be at the ordered pair -2, 2. And if I go to the left by 3, I will be at -8, 2. So when I connect these, I can use those as guide points for a circle. And that was a lousy circle, but you get the idea. There, I fixed the circle, and that's it. Basically, the distance formula and the formula for a circle both come from Pythagorean theorem, and they are easy to use.